right, well, we've simplified radicals, added, subtracted, multiplied, so naturally we would divide radicals as well. So that is today's topic. So the quotient property says if you have the nth root of a over b, you can rewrite this as the nth root of a divided by the nth root of b. Now we have this property in roots that we don't leave a root on the bottom. And what we call this is rationalizing the denominator. Rationalizing the denominator. Let me see what that means again. We don't leave a root in the denominator. So what we do is we multiply the denominator by itself. Because any root times itself, remember, is just itself. So I end up getting just b and the nth root of ab. So radicals in the numerator are okay, but we don't leave radicals in the denominator. We rationalize the denominator. So a radical is in simplest form when the radicand has no factors that have a greater power than the index. There are no fractions underneath the radical and no radicals in the denominator. So lots of different types of examples you'll see here today. And then we'll get to the bigger ones near the end. All right, so number 1, 2 over root 3. So my problem is no radicals in the denominator. So we call this rationalizing. We literally just multiply by itself. And the whole point, remember, is that any root times itself is just the number under there. So root 3 times root 3 is really just 3. When I multiply the tops, remember we talked about multiplying, you do outsides and insides. So this is just 2 root 3. And this can't get simplified. I can't reduce 2 and 3. I can't break down this root 3. This is as simple as it's going to get. All right, let's try number 2. So I have the square root of 7/8. So I'm going to break this up as the square root of 7 over the square root of 8. Okay, so my brain's saying, okay, no radicals in the denominator. So I'm going to multiply by itself. And I've got radical 8 times radical 8 is just 8. And 8 times 7 is 56. All right, so now I've got to ask myself, can 56 get simplified? So, well, itself is not a perfect square, but is there a perfect square that goes into it? And maybe that one's not as obvious. Let's start trying here. My first perfect square is 1, then it's 4. Oh, 4 goes in there. So I can break this down as root 4 over in root 14, all over 8. And then I'll say, oh, I know the square root of 4 is 2. So I get 2 root 14 all over 8. And then I can reduce that fraction to say 2 over 8 is 1 over 4. So I've got the square root of 14 over 4. Okay, so again, I rationalize by multiplying by itself. Then I'm going to simplify the radical if I can and reduce. Let's try 3. I'm going to rewrite this as the cubed root of 8 over the cubed root of 27. I kind of like those. I do know the cubed root of 8. The cubed root of 8 is just the number 2. And the cubed root of 27 is just the number 3. So we just get 2/3. Seemed too easy. Okay, now we're starting to get ugly. Let's take a look at the next one. Move that over. Okay, I've got the cubed root of everything. So I'm going to kind of break this up. So it's the cubed root of 16. Now these variables I always write as fractional exponents. So remember, the roots go on the bottom. So this is x to the 4/3 and y to the 9/3. Now this isn't that bad. I know the square root of 16. It's just the number 4. Okay. let's see, 4/3. How many whole x's can go in? 1 can go in, which tells me I have 1 left over. So I have the cubed root of x left over. This is 9/3. 3 goes into 9 a perfect 3 times, so I think I just get y cubed there. And that's as simple as it can get. All right, let's look at 5. All right, I'm going to rewrite this as x to the 5/2. Lots of fractional exponents. And now I'm saying, oh, this is elementary. We've been doing this for a long time, since Algebra 1. When I divide, I do what with the exponents? Subtract. So it's 5/2 minus 1. And when I think, obviously you can throw this in your calculator. When I do it in my head, I call this 2/2. So 2/2 is equivalent to 1. So 5/2 minus 2/2 should get me 3/2. So let's see. So no fractions are under the radical. We don't have that. So this, just to remind you, is equivalent to the square root of x cubed. Now, I'm going to say both of these can get simplified. Right? If this is the square root of x cubed, I can take 1 out, and then I'm left with 1 inside. So I'm going to say that's equal to x root x. 2 goes into 3 once, 1 comes out, and I have 1 left in the house. All right, 6, just another old review problem here. I'm going to rewrite each of these as fractional exponents. So I have x to the, roots go on the bottom, 4/3, x to the 5/2, x to the 1/7. Okay, now I have all like bases, right? They're all x's. So what comes naturally? Multiplication tells me to add the exponents. So I've got 4/3 plus 5/2, math frac. That gets me x to the 23/6 and x to the 1/7. Now again, naturally I see division, so I should be saying subtract. So I'm going to take that 23/6 and I'm going to subtract 1/7. Math frac. I get x to the 155/42. Now that is ugly. All right, now let's say we wanted to simplify that. So remember, you're saying this is like the this is the 42nd root of x to the 155th. So 42 goes into 155 3 times. So 42 times 3 is 126. So I can take out an x cubed. And I'm left with 155 minus 126, x to the 29th. All right, we've got one more, hopefully nice review type question to tackle before we get to this new stuff here. So nothing to do on the top. I'm going to leave that as 2x to the 3/4. Okay, now the bottom, remember, everybody in here gets raised to the 1/3. So just to be clear, this 10 is only on the x. My exponent here on this 8 is a 1. So I'm going to get 8 to the 1/3 and x to the 10/3. Okay, so I didn't touch the top. Everybody in here got raised to the 1/3. All right, so I'm going to start with the numbers. 2 I can't do anything with. 8 to the 1/3 is really the cubed root of 8. We know that. The cubed root of 8 is a 2. Okay. Now, I've got x's on the top and bottom. That means I need to subtract those exponents. When we divide, we subtract exponents. So 3/4 minus 10/3 is going to get me x to the negative 31/12. All right, so what can clean up? These 2's can divide out. This negative exponent can move to the bottom, so I'm going to get 1 over x to the 31/12. And again, I could write that the 12th root of 31, or I could simplify 12 into 31 and see how it goes from there. All right, the last 4 problems, guys, are really what Algebra 2 is all about. We call this rationalizing the denominator. Okay, we said we cannot leave a radical in the denominator. So here is what we do. We multiply. Let's put a nice... We multiply by the conjugate. And again, if you're watching this at home because you missed class, pause it when you need me to slow down. Okay, sometimes I get into it and I start talking fast. Pause it, rewind it, go back. We multiply by the conjugate. All right, so the conjugate of who? Well, the rule was we cannot have a radical in the denominator. So I'm going to look at my denominator and I'm going to multiply by the conjugate. So the conjugate of 3 plus root x is 3 minus root x. And again, whatever I do to the bottom, I have to do to the top. So the way I see it on top is this is just distribute. So I'm going to get 6 minus 2 root x, outside, inside, all over. Now this is a binomial, so I've got to FOIL. 3 times 3 is going to be 9, minus 3 root x, plus 3 root x. That always happens in conjugates, remember. Positive times a negative is a negative, and root x times root x is just x. So let's keep cleaning up. So I have 6 minus 2 root x. The conjugate should cancel the middle terms, and on the bottom, I'm just left with 9 minus x. Okay. If I can't factor, I'm done. There's no factoring, we're just done. All right, let's try another friendly one like that. So I have 15 over root 5 minus 2. Can't have radicals on the bottom, it's more than one term, so we're going to multiply by the conjugate. Root 5 plus 2. 5 plus 2. All right, so again, it just looks like the distributive property on top. So that's 15 root 5 plus 30. On the bottom, it looks like a binomial times a binomial, so I've got to FOIL. First, outer, inner, last. First, root 5 times root 5 is just 5. Outer. It's going to get me a positive 2 root 5. Inner is going to get me a negative 2 root 5, which we love because they're conjugate, so those middle terms should cancel. And then the last is going to get me a minus 4. So just like we hoped, conjugates, the middle terms cancel. I've got 5 minus 4, which is just 1, so I have 15 root 5 plus 30 over 1, or just 15 root 5 plus 30. All right, how do they get a little uglier? Well, we'll put a coefficient in front and just work on our multiplication. So again, can't leave a radical in the bottom, so I'm multiplying by the conjugate. 2 root 2 minus 1. 2 root 2 minus 1. All right, so we're going to distribute outsides, insides. So 28 root 2 minus 14. Perfect. Okay, FOIL the bottom. Outside's inside. 2. Remember, this is going to turn into root 4, which just turns back into a 2. Feel free to write 2 root 4 if you need to. Minus 2 root 2 plus 2 root 2 minus 1. So let's see. On top, I still have 28 root 2 minus 14. On the bottom, those middle terms are canceling. 2 times 2 is 4, minus 1 is a 3. Now, I'm going to argue that this isn't done because I can factor the top. It looks like there's a GCF of 14. So I can pull out a 14, and I'm left with 2 root 2 minus 1 all over 3. Now, nothing ends up canceling, but I want to make sure I factor and try to cancel. All right, I think we've made it to the last one. By far the ugliest because I have a binomial on the top and bottom, but remember, the only part we care about is the bottom. You cannot leave a radical on the bottom. So we're going to multiply by the conjugate, root 3 plus 2. Okay, so the only difference is it's definitely a binomial times a binomial, so we're doing a lot of FOILing. So on top, root 3 times root 3 turns into root 9, but that just gets me back to 3. Plus 2 root 3 plus root 3 plus 2. On the bottom, root 3 times root 3 is root 9, which just gets me back to 3. Plus 2 root 3 minus 2 root 3, conjugates, minus 4. All right, so let's see. Those are going to wipe out because they're conjugates. And 3 minus 4 is going to get me a negative 1 in the denominator. 3 plus 2 is 5. 2 root 3 plus 1 root 3 should get me 3 root 3. Now, this answer's fine if it's short answer. If it's multiple choice, they're not going to leave divided by negative 1. They're actually going to divide everybody by negative 1. Now remember, we talked about equivalent fractions. You could just change all their signs. So this could be negative 5 minus 3 root 3 over a positive 1. And I would probably look for that multiple choice. All right, so we've got a little bit of everything on the homework. We're going to tackle all these. We have the nice review like the questions we did previously, and then we have all this conjugate stuff down here as well. So take your time. I'll get my answers posted on Google Classroom since they don't seem to be on the back here.